Section 9.6 Exponential and Logarithmic Equations. Okay, now the last topic regarding logarithms and exponential functions is to learn how to solve equations that involved exponential functions and logarithmic functions. Remember that knowing how to solve equations is really one of the most important skills that you're supposed to have coming out of college algebra. So the last two topics will be about how to solve equations. All right, so solving exponential equations, such as the ones we're going to be doing now, is really actually simple. The idea is, okay, we don't know how to deal with when variables are up there, when they are exponents. So what we need to do is to bring them down. Bring them down. And once you bring them down, then you can move them around to the other side and get rid of coefficients and things like that. But while they're up there, you cannot really do anything. So the idea is to bring them down. And how do you bring them down? Is by using the property of logarithms that says that if you have a logarithm of a power like that, then you can bring the exponent to the front and get this. So that allows you to take exponents up there and bring them down. So the idea is that you have variables up there as exponents, so you can bring them down by taking logarithms. So we're going to take logarithm on both sides and you see what's going to happen. You can take uh, any logarithm, but usually I take ln. ln, the logarithm with natural base is the most commonly used one, so that's the one I use. But in theory, you could use any base for the logarithm. Okay, so taking ln, putting ln on both sides, you get ln of the left, which is 7x, equals ln of the right. So ln of 7x, of 7 to the x, equals ln of 5. All right, now using that property of the logarithm that I just reminded you of, the x moves to the front, so this is going to be x ln of 7 equals ln of 5. And now lastly, ln of 7 is a number. That's just a number. You can put that in the calculator. We're not going to put in the calculator, but I'm saying this is just a number. So it is like having, it's like having x times 5 or 5x. So that thing is just a number. So you know that if you have something like this, to solve for x, you would divide by 5. Right? You would divide by 5. Similarly here, this is just a number. So to solve for x, we just divide by ln of 7. So that means x is going to be ln of 5 over ln of 7. And that's the answer. Now, we could put that in the calculator to figure out exactly what x is, but we're not doing that. If the homework asks for it, then you do it, but we're going to leave it like that. So that is x. X would be, in this problem, ln of 5 over ln of 7. And that's it. And that is the idea in all of these problems. To bring variables that are in the exponent up there, you bring them down by just taking ln on both sides, and immediately then use the property of logarithm to bring the variable down, and after that point, you can just manipulate as usual to solve for x. All right, so here's another one. 4 to the 3x minus 2 equals 17. Okay, the x is up there as an exponent, so we're going to bring it down. And we're going to bring it down by taking ln on both sides. So this is going to be ln of 4 to the 3x minus 2 equals ln of 17. Now, using the property of logarithms, this exponent right here, 3 x minus 2, all of that is the exponent. The whole 3x minus 2 moves to the front. So this is going to be 3x minus 2. The whole thing moves to the front. ln of 4 equals ln of 17. Okay, now you could either divide by ln of 4 or you could distribute, okay? Both are appropriate steps to take uh, now. So you could do either way. There's not one way of solving for x. So again, you could either distribute or just divide by ln of 4 as your next step. It doesn't matter which one you do. I'm going to distribute. So, okay, so I'm going to distribute. So multiply ln of 4 by that and ln of 4 by that. You're going to get 3 ln of 4. So I'm putting the numbers first and then the x, because we normally put the numbers uh, in front of the variable. So I'm putting both the 3 and the ln of 4 in front of the x, minus 2 ln of 4 equals ln of 17. Then, two more steps, we're going to move this to the other side. So we're going to get 3 ln of 4 x equals, moving this to the other side, you're going to get 2 ln of 4 plus ln of 17, or you could write it the other way, ln of 17 plus 2 ln of 4. And lastly, divide by this, and you get what is the answer. You get what x is. So this is going to be 2 ln of 4 plus ln of 17. All that divided by 3 ln of 4, and that is the value of x. All right, let's tackle the next one. The next one says 5 to the 2x equals e to the 3. Same deal. You want to bring that x that is high up there, bring it down so you can manipulate it and solve for it. So to bring it down, take ln on both sides. So ln of 5 to the 2x equals ln of e to the third. Then, using the property of logarithms, the 2x moves to the front. So this is 2x ln of 5 equals, and here, this exponent here that you see, this 3, this cube moves to the front. So the 3 moves to the front. So this is 3 ln of e. Now you should always remember that ln of e is 1. That's something that you should know. You should know that ln of e is 1. So that means this ln of e right here is actually 1. So you would get 2x ln of 5 equals 3. Now, normally though, remember that we usually put constants in front of the variable. So ln of 5 is a constant, it's just a number. So normally we would write this like this. 2 ln of 5, put that in parentheses, x equals 3. Numbers go in front of the variable. All right, and now lastly, we divide by this and we get x. So x is going to be 3 over 2 ln of 5. And that's the answer. Now, sometimes people solving this same problem can arrive at differently looking answers. So for example, another way I could have given that answer is if I use the property of logarithms and move the 2 inside the logarithm when I move it as an exponent, then I could say that this is the same thing as 3 over ln of 25. This will be actually then the same answer, because you can move that 2 inside the logarithm as an exponent, so it will be like ln of 5 squared, and 5 squared is 25. Similarly, you could do such things here. You could move these 3 inside, and it would be like 4 cubed, which is 64. So at the bottom could be written as ln of 64. And these 2, you could move it inside, and you would have ln of 16. Then you could combine the 2 logarithms that are being added together as the product of the logarithm. So there's many ways in which you could rewrite this or simplify it or offer the answer in a different looking way. But either way, both are acceptable. There's no reason why I would prefer this over the other one. Okay, now let's do another one. It says 15 times e to the x, all that over e to the x plus 6 equals 5. Okay, the first thing we need to do here is multiply both sides by the denominator. Multiply both sides by the denominator, or if you want to think about it like that, you can imagine as 5 over 1, this 5 is 5 over 1 and cross multiply. Either way, whether you cross multiply or you multiply by both sides by the denominator, you're going to get 15 e to the x equals 5 e to the x plus 6. Okay, then distribute here. So this is distribute the right hand side. So this is 5 e to the x plus 30. 5 times 6 is 30. Then you want all the x's on one side, so you have to move this. You're going to have 15 e to the x minus 5 e to the x equals 30. And then these are like terms, so you can combine them into just a single term, which is 10 e to the x. 15 minus 5 is 10. Then 10 e to the x equals 30. Then you divide by 10, so you get e to the x equals 3, because 30 divided by 10 is 3. And now it is at this point that you take the ln on both sides. You see, you only want to take ln on both sides to bring the variable up there down once you have an exponent that is like that all by itself. You see, if I have other stuff going on in there, I couldn't just do it. In all these 3 examples, you had only an exponential on the left-hand side. So you could take ln on both sides right away to bring down the x. But here, I didn't have just an exponential, I have other stuff going on there. So you need to then simplify as much as possible until we have just an exponential on one side, like that. Now I can take ln on both sides, and this is going to be ln of e to the x equals ln of 3. The exponent goes to the front, so you would have x ln of e equals ln of 3. And lastly, remembering then that ln of ln of e equals 1, remembering this fact, then you know that this is 1, so you get x times 1, which is just x, equals ln of 3. And that is the answer to that problem. Okay, this example says solve the given equation, and this is a typo. It should say for t, because all the equations are in terms of t. T is the independent variable. So solve the given equation for t. So I'm going to do, I'm going to do them all, but you should try and see if you really understood, because this is just more examples of the same thing. If you understood the previous example, well, we did all those equations, so you should pause the video and see if you can solve these equations. All right, let's start with A. Then remember, I shouldn't just take ln on both sides right away. I want an exponential all by itself first on one side. Doesn't matter if it's the left side or the right side, but I want an exponential all by itself before I take ln. Right now, I don't have an exponential all by itself. I have 4 times this exponential. So my first goal is going to be, first step I'm going to take is going to be to get rid of that 4. I don't want that 4 there. So divide both sides by 4. We're going to divide both sides by 4. If you divide the left-hand side by 4, you get 9. If you divide by the right-hand side by 4, the 4 goes away and you get just e to the 5t. So the first thing you should do is divide both sides by 4, because I wanted the exponential all by itself. Once you have the exponential all by itself, then you can take ln on both sides. So taking ln on both sides is going to become ln of 9 equals ln of e to the 5t. Then I want to move this 5t to the front, so this is going to become 5t times ln of e. So move this 5t to the front using the property of logarithm. And lastly, you have 2 more steps. Remember that ln of e is 1, so really then this is ln of 9 equals 5t, because ln of e is 1 and times 1 doesn't do anything. And to get t, divide by 5, so you're going to get t equals, divided by 5, ln of 9 over 5. And that's the answer. Again, if you didn't try that one, B, you should pause the video and try it. Okay. Assuming that you tried, let's compare notes. Let's do it. So first thing, I want all the t's on one side. I cannot take ln just yet. I want everything that has t on the same side, so it's going to be 2. And I'm going to move this one over here. So this is going to be 2, 11 e to the 3t minus 5 e to the 3t. Now, these are like terms. They both have e to the 3t, so these are like terms. So that means I can combine them into a single term. So 5 minus 11 is 6. So this is 6 e to the 3t. Now, I don't have an exponential by itself yet. I have 6 times an exponential. So the next thing we need to do is get rid of that 6. So divide by 6 on both sides. You would have on the left 2 divided by 6, which is 1/3. So I'm going to write just a third. 2 divided by 6 is a third. So a third equals e to the 3t. And now you can take ln on both sides. So this is going to give us ln of a third equals ln of e to the 3t, which is equal to, you can move the 3t to the front, 3t ln of e. Now ln of e is 1, so this is not needed, this is just 1. So you're going to get then that ln of 1/3 equals 3 times t, and divided by 3, you get that t equals ln of 1/3 over 3. That's our answer. Ln of 1/3 over 3. Now you could rewrite the answer. As I said, you could rewrite this answer slightly differently. That is perfectly fine. But you could write this. You could use other properties of logarithms to offer this answer slightly differently. You could say ln of 1/3 equals, well, that's a quotient, so That will be the ln of the numerator minus the ln of the denominator. Now ln of 1 equals 0. That's another thing you should know. You should know that ln of e is 1 and the ln of 1 is 0. So this is negative ln of 3. So that means that the top is actually negative ln of 3. So another way I could give that answer would be as t equals, instead of writing ln of 1/3, I could write negative ln of 3 over 3. So that would be another way of giving the same answer. Okay. So now let's do the last problem. From the last one from example 2. Solve for this. Okay, I want an exponential all by itself, so move the 4. You're going to have 2 e to the 6t equals negative 4. We need to get rid of that 2, so divide by 2. E to the 6t equals negative 4 divided by 2, that's negative 2. Then, if you take a ln on both sides, I mean at this stop you can stop. This is impossible. You can never have an exponential give you a negative number. This is as ridiculous as having something like this. As having absolute value of t equals negative 2. You can never have the absolute value of a number being a negative number. That is impossible. There's no value of t that you can put in here that makes this true. You can never have the absolute value of a number of anything b equals a negative number. Similarly for exponentials, if you remember the graph of an exponential is always above the x-axis, meaning that just like the graph of the absolute value, it's always above the x-axis, meaning that you can never have either an absolute value or an exponential be equal to a negative number. That is impossible. So actually then, you can say that there's no solution. Immediately right here, you can say that there's no solution. Full stop. If you didn't remember that, you could always, if you keep going, you would get ln of e to the 60 equals ln of negative 2, and then you should have noticed it right here then. You can never have the logarithm of a negative number. You can never, if you try to plug in a negative 2 in the ln in your calculator, you're going to get an error. So this is impossible. That means there's no solution. You cannot solve this. Because the right hand side does not exist. So at one point or another, you should have noticed that there's no solution. Either at this point or once you take logarithms. This is nonsense. ln of a negative number is not real. All right, so this is an example of something that has no solution. Okay, let's do a few more. Now let's do a problem where you have two different bases. Two different types of exponential functions equal to each other. The way you solve this is exactly the same though. It doesn't change. So suppose that 2 to the x plus 1 equals 3 to the x. So you want to bring that x down in order to be able to manipulate it, move it around. So take ln on both sides. Ln of 2 to the x plus 1 equals ln of 3 to the x. Now using the property of logarithms, I can move that to the front. You would have x plus 1 ln of 2 equals x ln of 3. Okay, now just move the exponents to the front. The x plus 1 is an exponent, moves to the front, and the x moves to the front. So x ln of 3. And now I want to solve for x, so I need to have all the x's on the same side. However, this x is inside these parentheses, so I need to get it out of there first thing. So I need to distribute this. So distributing, you have x times ln of 2, x ln of 2, and then plus 1 times ln of 2, which is just ln of 2, equals x ln of 3. Then I want all the x's on the same side. Everything that doesn't have an x needs to go to the other. So you would have x ln of 2 minus x ln of 3 equals negative ln of 2. Okay, I move this to the left-hand side, and the ln of 2 moves to the right-hand side. Two more steps. Factor out the x, which is common. X is repeated, so factor it out. When you pull it out of here, you get ln of 2. When you pull it out of there, you get ln of 3. And now we are almost done. Now I divide by this number and I get x. So this is ln of 2, all that over ln of 2 minus ln of 3. And that's the answer for that one. Okay, this one I don't think I'm gonna try to force this whole solution in this space. I'm gonna write C, next page, and I'm gonna do it in a separate page. Okay. All right, now let me copy that here. 5 to the 3x equals 9 to the 4x plus 1. Okay, let's solve this. You should pause the video here and try it on your own. See if you can get it. Now let's solve this. Take ln on both sides. Ln of 5 3 to the x equals ln of 9 to the 4x plus 1. Okay, take the exponent, move it to the front, 3x, ln of 5 equals 4x plus 1, ln of 9. Now I want all the x's on one side. All the things that have x on one side, I need to get this x from out of inside that parenthesis, so we need to distribute here. And I'm gonna put, as I did in another problem up there, the previous problem. These ln of 5 is a constant, 3 is a constant, and we usually put constants in front of the variable. So I'm gonna write this like that: 3 ln of 5 x. Put both constants in front of the variable. And then same here. When I distribute, you would have 4x ln of 9, but I put both constants in front of the variable because that's a better habit. It's not required, but looks better. And then plus ln of 9. Now I want all the x's on the same side, so move this to the other side. You're going to get 3 ln of 5x minus 4 ln of 9x equals ln of 9. Now you're going to factor out the x because it is common. factor out the x. So x times 3 ln of 5 minus 4 ln of 9 equals 11 of 9. And lastly, divide by this number and you get the value of x. So x is going to be equal to ln of 9, all that, that divided by 3 ln of 5 minus 4 ln of 9. And that's the answer for that one. Now, to finish up this section, we would like to solve some equations that have logarithms in them. In all the previous equations that we solved, the original equations did not have any logarithms. We just used logarithms as a tool to solve it, but the original equation did not have logarithms. None of them had a logarithm in the original equation. Now we would like to solve some equations that have logarithms in the original equation. Okay, so for this we're gonna use the little diagram for interpreting logarithms in terms of exponents. So it was like this. So suppose we have logarithm of base b of x equals y. If you have such an equation, you can translate this using the diagram that I showed you. It's like a circular diagram. This means that b to the y, you go full circle, equals x. So b to the y equals x. So you can then take any logarithmic equation like that and reinterpret it without logarithms. And that helps in solving logarithmic equations. So here's the diagram in action. Suppose I want to solve for this equation for x. Well, first thing is you need the logarithm all by itself before you can apply the diagram. See, I can apply the diagram only when I have a logarithm all by itself on the, let's say, on the left-hand side. Once I have the logarithm all by itself equals something, then I can apply the diagram. So first thing is solve for x. Solve for the logarithm. Isolate the logarithm. So move the 2 to the other side. You're going to get 3 ln of x equals 8. Subtracting 2 from both sides. Or moving the 2 to the right. You move the 2 as minus 2. So 10 minus 2 equals 8. Then divide by 3 to get the logarithm all by itself. You're going to get ln of x equals 8/3. You have ln of x equals 8/3. And now, remembering that logarithm ln is the same as logarithm base e, you can say this is the same as log base e of x, because that's what ln of x is. And then you can apply the diagram. This means that e to the 8/3 equals x. So that means e to the 8/3 equals x. So that's what x is. X equals e to the 8/3. Okay, one thing that we need to be aware of is that when we solve logarithms, logarithmic equations that have logarithms in them, we have to make sure that when we solve for x, the answer that we get is in the domain, meaning that it's something that you can actually plug in the original equation and not get something that is a third. And by a third means something that is not in the domain. Remember that the domain of a logarithmic function is positive numbers only. So if I had like x equals -1, I couldn't plug that in there because ln of -1 doesn't make any sense. I cannot plug in a negative number inside a logarithm. But this one is fine because e to the 8 over 3 is a positive real number. This is positive. This is not negative by any means. This is positive, and you can plug in positive numbers in the logarithm. So this actually is fine, meaning that is in the domain. So that is good. So that is the value of x. So when you have logarithm equations, you always need to double check that the answer makes sense. All right, let's do another one. Log 4 log base 3 of 9x minus 8 equals 0. First, isolate the logarithm. You need the logarithm all by itself on the left. So I'm going to move the 8 to the other side. You're going to get 4 logarithm base 3 of 9x equals 8. So I move that minus 8 to the right hand side. Then I need to divide by 4. So this will be log base 3 of 9x, and dividing by 4 gives me 2. Dividing by 4 gives you 2 on the right hand side. Finally, we can apply the diagram now that I have the logarithm all by itself. The diagram tells me that 3 to the 2 equals that thing that is inside the logarithm, 9x. 3 to the 2 equals 9x. In other words, 3 to the 2 equals 9x. Now, 3 to the 2 is 9, so you get 9 equals 9x. And if 9 equals 9x, that means that x has to be 1, dividing by 9 both sides. So x has to be equal to 1. And that's it. But remember that you should always check whether you can plug it in or not. X equals 1, I can plug it in there because I don't have, if I plug it in there, I would have 9 times 1, which is 9. And 9 is a positive number. And that works. You can plug in, as long as you get a positive number inside the logarithm, that's fine. If we had got something like x equals negative 2, if x equals negative 2, you would have negative 18 in the inside the logarithm. And again, you cannot have negative numbers inside the logarithm. So that means we would have to discard that. But 1 is fine in this example. Okay, the last two are a little bit more, slightly more complicated because we have now 2 logarithms, but not by a whole lot. We have 2 logarithms, however, we now know how to condense logarithms. So if you have multiple logarithms, you can just condense them into a single one. So this is not a big deal. So for example, this one, you can condense that logarithm, those 2 logarithms into a single one, using the properties of logarithms that says that if you have a sum of 2 logarithms, that is the logarithm of the product. So that means it is the logarithm of x times x minus 8. So the sum of 2 logarithms is the logarithm of the product. So the logarithm of x times x minus 8. And now that I have the logarithm all by itself, on the right hand side, on the left hand side, I can apply the diagram. So this is going to be 9 to the 1 equals this. So 9 to the 1 equals x times x minus 8. All right, which means 9 equals, and now distribute this, x squared minus 8x. And now you see that this is a quadratic. In a quadratic, you know how to solve this already. So we're going to move the 9 to the other side and get 0 equals x squared minus 8x minus 9. And then we either factor or use the quadratic formula. I'm going to factor this one because it factors easily. It factors is x minus 9, x plus 1. So this means that x equals 9 or x equals negative 1. So we have two possible values of x. But now we have to check whether both of them work, only one of them works, or none of them works. Just by checking whether they are in the domain or not. If you plug in x equals 9 here, you would have a 9 inside this logarithm, which is fine. If you plug in 9 here, you would have 9 minus 8, which is 1, and you can have positive 1 inside the logarithm. So this one is fine. Now, for x equals negative 1, if you plug it in there, I would have a negative 1 inside that logarithm, so that does not work. That is impossible. You cannot have that. So I can discard it right away. I don't even have to try the next one, although the next one also gives me a negative number inside the logarithm. It would give me negative 9 inside this logarithm, which again, you cannot do that. So you would have only one solution, x equals 9. Okay, lastly, when you have two logarithms equal to each other, you can use the property of one-to-one. The fact that logarithms are injective or one-to-one, meaning that you have two logarithms equal to each other here. So these are like two outputs. And if two outputs for a one-to-one function are the same, then the inputs have to be the same. So this means that 2x minus 1 equals x squared. And this is because ln is 1 to 1. It is injective. So if two outputs are the same, the inputs have to be the same. You have two logarithms like that equal to each other. The inside of the logarithms have to be equal to each other. Okay? I mean, this is we use this property of being one-to-one when we solved our very first examples of exponential functions. We had like something like, I don't remember the exact numbers, but it was like pi to the 4x minus 1 equals pi to the 2x, something like that. These are two exponentials. Exponentials are also one-to-one, so we said, okay, the bases are the same, the exponents have to be the same. This is one-to-oneness. So similarly, we're using the property of one-to-oneness here. If you have two logarithms, as long as the bases are the same, and they are, then the inputs have to be the same. All right, once you have that, then this is going to be moving, this is a quadratic, you know how to solve a quadratic. Move everything to one side so you get 0, so this is x squared minus 2x plus 1. And then either use the quadratic formula or factor, so this is x minus 1, so you get that x equals 1. And make sure that this works. If you plug in 1 here, you get 2 times 1, which is 2, minus 1 is 1, so you get a positive number, which is fine. These negative numbers that we're trying to avoid. And if you plug in 1 here, you will get 1 squared, which is positive. And that's in the domain. Okay, so that means this works. So x equals 1 is the solution. And that completes that section.